Hello, welcome back to Sushi Live Noding. In this episode, I'm gonna share with you a kind of setup that can do this. It's basically this kind of random scaling, and this is actually can be randomized as well if we are using the seed value. So yeah, you might have seen like effects like this happening, but I'll show you how to do it using Sverchok. So it's not actually that complicated. It's basically we just need to separate all the faces and then kind of create a setup where we have like a multiple array of value coming in and kind of passing the data per face. So you can see like you will for this kind of effects you will get this kind of number happenings because we are working on the array of values, and so we are separating the data so they're kind of working together. For hexagrid, actually we already have a way to do that by using the scaling. I believe the scaling can be vectorized as well, so you can kind of scale it like this pretty easily. Although if you actually switch to something like plane, for example, this guy is going to behave differently. So yeah, we want the setup to work on any kind of mesh input, whether it's like Suzanne or any kind of input. It will scale the polygon like that. So that's the effects we're gonna do. So I'm gonna start from scratch. Hopefully everything works like smoothly. If it doesn't work, I'll give you the final setup anyway. So let's get started. So this is scaling every face individually. So this kind of effects, I think we have it. We sort of have it with this modifier, build modifiers, kind of doing that. But it's more like a visibility. So we're gonna do it. We're gonna do it using Sverchok, and we're gonna try it on the torus at some point. Save it. Sverchok. Start with a plane. MK2, MK1. Start with it. Let's just use MK1 for now. Viewer draw. Quickly have a look. Again, we can work. I think we can work with this 9 polygon face for now. So first of all, we just gonna need to separate it. Separate polygon using polygon boom. So this gonna separate all the polygon face for us. And then we just need to do scaling. Scale. Polygon scale, and this should go in there, and then the center should be the center of polygon itself. Center of polygons. We do need this this node right here to get the center of the polygon. This goes in there, this goes in there, and we have the effects already happening. So, but now the tricky bit is actually to provide some kind of value here that can randomize the vector, and it needs to go from 1 to 0 and being clamped. So that's the tricky bit. Okay, so it depends how you want to control this. You can, for example, like if you just plug in random number into this guy, we know that we need 9 array of data coming in through this guy. I believe this is already kind of working. Well, actually it doesn't work. You see, this is like we have 9 lists of data, but when we plug it in, you can see this is like only 1 data coming in. So you need to separate that somehow. We can try using list split. I think list split does the job. And list split, yeah, I think list split 2 actually split the data. If you look at it from the stethoscope, this is the data after we split it. Maybe we didn't split it properly. There you go. It's supposed to be like this. This is the data after we split it. You can see the bracket there. There's a bracket kind of surrounding the value. This is the data before. So before is just like a list of number. After we split it, it's become like 9. Data become 9, and then we can pipe it in, and then it sort of work. We can see randomize the scaling that way. That's actually like we are kind of there. So you can see that in order for this to work, we need an array of data. For example, this is a value, and then we need to split it into 9 different data, and then each one of them need to go from 0 to 1 and being clamped. So it shouldn't go any lower or higher, and this guy can be randomized, kind of an offset. In this case, I want to use just a frame, like a time frame for that frame info node. So we know that we don't want random number, we want like a data that's kind of like a remap of the data. So this is for example, this is a frame, right? It's a time from 0 to the end of time, and we are passing it into this guy. And let's say if we want everything to grow from 50 to 100, this is like a time, and this is the value 0 to 1. This should actually work. So there you go. See, because it's being clamped as well, so the value doesn't go under 0 or beyond 1. So you can see that between frame 50 to 100, everything start growing at the same time. So the next thing we want to do is just to separate or just want to add randomizations. You can use vector noise, you can use random number, it doesn't matter. Basically, if you add I believe once we split it, if you add random number, or maybe I should add it before. Maybe I should, yeah, I should add it before. If you add it there, see, this is add and random number between, let's say, between 30 and 30. Hopefully this works. Where we have split 10, actually it should be 9 here. We can check using the stethoscope and look at the data. So you can see, you get it. It's like the data after we remap it. You can see we have 1, 2, 3. We have 9 stream of data coming in, and each one of them kind of growing from 0 to 1. So I think that's kind of complete our job here. So I think we are actually done. It's actually easier than, to explain than I thought. Let's arrange this 9 data. Okay, in order to make this like a better setup, let's say I want to increase the number of the plane, for example. We need to have like a 1 node that get the total number of the polygons. Currently we have 9, but we might change it, right? So we need to be able to do that automatically. So this should go in there. We use this length all the time, actually. So now if I increase the number, 7 by 7, we have 49. How many faces we have now? 144, 100. Now be careful with this. Suddenly we have 144. This is actually a big mistake there. Now I just made a mistake. Apparently we have 144. Why? Where is that from? Where is that number from? Maybe 36 by 36 of data coming in through this guy. So that's not good. Check the list length. Okay, apparently I did it wrong. This should be at level 0. So now, okay, now everything is correct. So this is something you need to check all the time. If you're dealing with a lot of data at the same time, you need to make sure that this works properly. Imagine if you want to bake it, actually, you also want to make sure that when you bake it, you don't end up with so many objects like this. That's actually not so great. It's better if you kind of list, you join all the mesh together. Sometimes you want to do that, and I think this is probably better. If I bake it now, these guys become a single object, so it will not make Blender slow or anything, and you can bake it into a single object as a what do you call it, file export. Alembic, for example, if you want to bake it as Alembic, you can easily do that, if I'm not wrong. So we can try to do that real quick. So this will work with any objects. For example, if we have a torus and we bring it in, get our torus and plug this guy into that guy, we should have the effects happening. We have a lot of points there. I'll hide the points and I'll hide the edges as well. So this is the effects. Start from nothing, and then as you scrub, you can see them growing until all the faces become one object again. So that's pretty cool effects. It's pretty basic, but it's cool effects. And if you want to try to bake it, for example, I'll save this real quick. We have 576 like a polygon face. That's okay, it's not too big. We can handle it. Vmesh viewer and try to bake this out. So this guy, if I'm not wrong, this should work fine. Let's bake it from frame 0 to 150. File export as Alembic 150. Selected object only. Export Alembic and just wait for a few seconds. Normally you can look at it from the frame number here. Let's just wait. So the setup is rather simple. The procedure is pretty clear. Polygon boom, separate all the polygon faces, get the center of each polygon, and then just plug a stream of, we split the frame, this is like the time, and we split it into the number of polygon face, and then we do it, and so on. We scale, that way we can scale each polygon separately. There's actually another way to do this. So instead of having like a stream of data that coming in like a list, you can kind of try doing it differently. Let's say maybe you can control it by the distance. The distance is always kind of interesting. Similar kind of like a what I did to displace modifier, and then you have like the original position of the object, and then you have the displaced position of the objects, and kind of comparing the distance, and then by doing that you really have control over each of the faces instead of currently it's like just random stream of data coming in. But if you are using the distance based on the original face. Maybe that's if you have more control that way. Blender just decided to restart itself, so I'll restart it, and we're gonna check the Alembic data. I think it should work. Every now and then with a procedural thing, you want to bake it anyway. So it's good always to test it with a Alembic file, import Alembic desktop, and this guy, and we have nothing. Doesn't seem to work. Well, seems to be fail. Sometimes there's a way to kind of force it to bake. It's just doing this displacement and then zero it out. I'll try again, sorry about it. Export Alembic 1 to 150, selected object only, export Alembic. Okay, we have to start again and wait a few seconds, sorry about that. With random number, you can also use vector noise. So this map range kind of interesting. When you use the frame and add this map range, you can kind of offset the time. It's very useful for animations. You kind of want to offset things to get like more natural effects. So like I think in animation principle, there is one principle that says everything shouldn't start and stop at the same time. If you want it to be natural, there should be some kind of lag and offset. One of the principle. This guy, is this guy supposed to be separate? Huh. That's interesting. Okay, we are done. I'll try to just import the Alembic here. It's promising. Seems like it's doing its job. So that's the Alembic actually. Let's switch this to layer 2 and then just check it out. Yeah, there you go, that's the Alembic. I'll delete everything in Sverchok, and then you see this is the Alembic, and that's actually super fast. Switch to 3D view and then switch this to timeline, and there you go, that's the Alembic. Let me double check, is this really the Alembic? Stop this, stop it. Alpha 0.01, and this thing has this Alembic mesh sequence cache, and also it doesn't have object constraint, but this is the Alembic. So there's a proof. So it's become really fast. You can scrub it like super fast. This is super interactive, and you can have like a multiple of these objects, and you can also kind of offset the timing. I'm not wrong. Oh, this offset currently works for every single object. If you want to do an offset, you need to make sure the data is it's become like a, what do you call it, single user. So currently one same data is used by 6 objects. If you make each one of these like a single user, you can then offset them like individually. So that's the theory anyway. Okay, so that's pretty much it for this live coding. Hopefully this is useful, and if you have any question, let me know, and I'll see you in the next video.